Hello and welcome to the online learning session ABB IBAS KNX Switch Actuators Energy Functions in Detail. Our online learning session take around 30 minutes, today a bit more, I think around 45 minutes. The focus is always on a special topic of a product or selected function of a device. Today we talk about the energy functions, our new switch actuators in more details. My name is Thorsten Reibel from the ABB Competence Center Europe Smart Buildings, and together with us is Jürgen, and both of us will present today. As always, we record this session, so later you get the feedback email, video and also presentation, and still today I will send you at least the PDF file of this presentation. What is planned for today? We talk about our new switch actuators with energy functions. We did it already last week together with the webinar and the market launch of this product. But today we would like to go in some more details of some special functions around this energy function of this component, which has to do with the energy consumption, load monitoring and contact status supervision. This will be my part, and then Jürgen will continue with the integration of these switch actuators together with the energy analyzer QAS. Has to do with processing of data, but also with the so-called load control or load shedding, which is possible with both devices, the switch actuator with energy functions and the energy analyzer KNX. So let's start with the energy consumption. What does it mean? We measure first of all the current per channel in each device. That's the basis for a lot of more functions. Out of the current measurement and typically a constant voltage level, we can calculate the power, and multiplied with time we have the energy consumption in watt hours or kilowatt hours per channel available. So we can really check what is the energy consumption of each channel in such a switch actuator. So can be sent on the bus as values in watt hour or kilowatt hour. And when do you send it on the bus in case of change? Cyclically you can send it, but also on request with a dedicated group object to ask for the value. So we have a total meter available, counting all the time, but we have also so-called intermediate meter available. So we can start with an additional object, an intermediate meter per output, to have the energy consumption at a certain period. And if you take the total meter, you get also the start time of this measurement, and this will be shown then with individual group objects. So if you have the start time available, what does it mean? We have to assign the time to this device, and such a switch actuator is not having any internal clock, so we have to synchronize date and time to the actuator to synchronize the internal clock, and this has to be done by an external clock, of course. But there are so many components normally in a KNX installation to do so, and like touch panels, like weather stations, for example. And to have a precise time, we recommend to synchronize the time of this device, so around every hour. How to do this? You can enable group objects, set time and set date. You see it here on the right as 3-byte objects, or a common object for date and time is 8-byte data format, and to this objects you can send from anywhere date and time, for example from a weather station. This is possible, so every hour, let's say. Or you have here a request object which can be sent out to an assigned clock to receive then the date and time information. This is also possible. And these telegram with this object will be sent once from the device after you have started the component, so after 30 seconds after the device start, it will be sent out. And then you get also date and time here on these objects, but I recommend to send from any clock every hour date and time, and then you have a precise clock inside. As mentioned, you can send them the value depending on the parameters. You can adjust this as well on request, cyclically, or in case of change. And in principle, if you start up the device, it automatically then calculates the energy consumption based on the current measurement, voltage and time. And so you have continuously then the energy consumption per channel available. If you have to make a download, application download later, again, you do not override this counting, this value. Yeah. And date and time can be read out in this case, but you can reset this timer. This is very interesting, different from normal energy meters where you cannot do this. We have a reset group object, you see it here, a 1-bit telegram has to be sent, and then I can reset the value to 0. Then I get the time and date of the metering start available, and of course also the value on a separate group object status total meter energy consumption 4-byte value. So after every reset, you get the value and the starting time, and then it starts to count again, of course. So it's very simple. But of course, anytime you get also the value here on this object if you have, for example, programmed cyclical transmission of the data. Yeah, and this intermediate meter is a separate start-stop group object, you see it here, and a separate status, also value information about the energy consumption. And here you can say, okay, during a certain time, maybe for 1 day, 2 hours, I would like to know the energy consumption. And you start with 1 bit, you stop with 1 bit, and then you have the value also available for this special period. So very simple, but very useful to get all the time these values if you want, per output, per channel in such a component. We have it per channel, yes, but we have it also per so-called energy group available, the energy consumption. Maybe you remember, we can create out of the channels of each device a so-called energy group. We say, okay, channel A, B, D, and E shall be one group, and I would like to know from this group, for example, also this energy consumption. Also possible, you see the same group object, the start time and date, and also reset is possible. What you do not have is an intermediate meter for this energy group energy consumption, let's say. But the rest is in principle the same. Yeah, this is the energy consumption. Let's continue with load monitoring. What does it mean? We measure the current. I repeat this again because it's the basis for a lot of functions. And another option is to monitor the load, not only regarding is it on or off, this is standard with any switch actuator, but what is the load, the current or power level during operation. And out of this information, which can be too much, too low, whatever, you can take some information, you can react on this as well. And what did we do here? We have it called load monitoring, and you can program here for current or power thresholds. And in total, we can enable 6 operating ranges with different load current or power behind. And these thresholds you can change here in the parameterization. It's possible, but later you will see you can also change it via Telegram or via the ABB IBUS tool if it's then in the future available. So these thresholds are available here, and as mentioned, you can evaluate either the current or the power, and these thresholds are, or these ranges are called maximum threshold, overload, operation, so normal operation, green, yellow is underload, and then we have standby. And below 0, current or power, of course, it's off. So the off level you cannot change, either it's on or off, so current yes or no, and the other thresholds you can change here. As mentioned, you can change it via bus or the ABB IBUS tool in future. And what happens if you're in one of these ranges? You get a telegram on the bus. You know exactly in which range of load I'm right now. And you can choose between individual 1-bit object. You see it here. I have it enabled here, 6. From on-off, standby, overload, underload, and so on. Or you can receive also 1-byte object, and there it's relatively simple. Value 0 means it's off, and value 5 means maximum threshold exceeded, and any value in between is then assigned to the other ranges here. So for each situation you get an individual telegram, 1-bit, or a value in the 1-byte telegram. And you see the thresholds These 4-byte objects can be, if needed, also changed via a telegram. So you can handle these thresholds dynamically if needed, if it makes sense. Yeah, here we have made a recording of this communication if we have different loads and we have different load ranges. So let's have a small look to these telegrams here. So we switch off the relay. Of course, then the status off will be sent. We have no power, 0 watt, and it's not an operation. It's false, this information, this 1-bit telegram, and it's off. So these two information you get immediately. Then we turn on, status on, and the power is 75 watt, which means we are in the normal operating range because the thresholds are programmed accordingly. What does it mean for our status information regarding load monitoring? It's in operation, normal operation, yes. And load is on. That's the further information you get. It's anyhow on. That's also true. So now reduce the load a bit to around 50 watt. Then we are in the so-called underload mode. Means we have not in operation information anymore. It's false. We are not in normal operation anymore, but we are in underload. No, correct. Then reduce by another 25 watt. We have only standby range now active. And yeah, no underload anymore, but standby is active. True. And last but not least, power completely off. So no power connected anymore. So 0 watt. Then we have no standby anymore. And this load monitoring, load on off is also false because it's off. It's really no power anymore. So that's the way you get then telegrams out of this parameterization. Yeah, let's make a small practical example. What could be the solution or the situation, the application behind? For example, you would like to turn off a printer in an office building if it's in standby mode or an energy saving mode. Typically you see this with printers, and you are during the night. So it's night mode means nobody is working in the office. And we can do it with an internal logic we have inside the switch actuator, a so-called gate, where we can enable and disable telegrams. What does it mean? The control input to enable and disable the value telegram is the day or night mode. So this should come from any external clock. It's not a problem in KNX. And then if it's enabled, means we have night mode and the printer is in standby mode. So this is a feedback from our load monitoring here. This value 0, it will be sent through the gate to the output and it will turn off the printer automatically. So if you are working longer and the printer is still active, so night mode is coming, nothing happens, you can continue to work. But then if it's going to this energy saving mode, the printer, then automatically the telegram 0 from the standby feedback will be sent and switched off the printer completely in the night typically. And in the morning the day mode turns on, then this relay again, printer is active, and you disable the control input, so any standby during the day is not evaluated, is blocked then. So a small but possible application, and two more without details. So if the load, for example, is in overload mode, harming the device, not really dangerous at the moment, but harming the device, and you can say, okay, after 1 hour I have to turn off, otherwise it's getting dangerous for the component, or vice versa, any loads in underload, neither good, anything wrong with the component behind, I turn off the relay, the assigned relay as well. So you have some more options here to evaluate and to react on any unusual situation. So let's come then to contact status supervision. I like this feature because it's quite a multi-purpose feature. You can use it for different purposes. What is behind this contact status supervision? In principle, we compare the status of the relay, open or close, with the current measured. And out of this, we can evaluate two typical situations. What does it mean? And for each of these two situations, we get an individual feedback. And one is contact open and current flows. Not good, not normal, of course. Or the other one is contact close, but no current flows. Neither okay. So what does it mean practically here? Contact close and no current flows. What could be the reason? Anything wrong with installation with the load behind. So cable interruption, circuit breaker has been tripped, device not connected or damaged. This is a very typical situation, especially with lamp loads. That's the way we monitor lamp failure in principle. Or the power is not connected anymore, the phase failure exists maybe. All these things could be the reason. So, and you have it as a feedback on the bus with a 1-bit telegram. Yeah, and vice versa, the same with the opposite situation, contact open and current flows. What could be the reason? Somebody has operated manually. Remember, we have no keypad to operate manually. We have a mechanical relay available from outside via the lever, and then we can operate it manually. And or the damaged contact could be the reason. So it's welded maybe, contact are glued and cannot operate it anymore. So we think it's open the contact, but it's closed at the moment, and that's the reason why current flows. So another individual information, and then of course you can check what could be the reason behind. And a further group object exists to reset such an alarm. Good, so then I would hand over now to Jürgen. He will go in some more details in the combination of the energy analyzer KNX with our new switch actuator and the energy functions. And I would like to hand over to Jürgen now. So Jürgen, please continue.
Okay, can you hear me?
Yeah, fine.
Good. Hello and welcome. Jürgen Schilder is speaking. I will start my presentation on load control with a few words about the ABB EQmatic Energy Analyzer QAS. These are web-based standalone devices for energy management applications. So we have three different versions. One is a so-called QAS KNX energy analyzer for M-bus and Modbus. The software feature, or what you can do later in the dashboard and the analytics, are nearly the same, but only the protocol of the meters is different. Like here on the right side, you can see the KNX energy analyzer. He gets all meter data via KNX. And of course, when you use the M-bus, then you connect M-bus meters or the Modbus meters. So the device has a web server built inside, so the end user can have access via a standard browser, via the IP address. Then he can see all the meter values. So the device has an automatically detection of ABB A and B series meters and some network analyzers, so it's not necessary maybe to configure all them. If you use for M-bus or Modbus third-party meters, then of course you have to do the manual configuration of these devices. So the KNX, all energy analyzers, QAS, they have at first a so-called dashboard for the end user. This is for the rapid overview of all the meter values. For example, some gauges like here to show some values like energy, power, frequency, or to make, for example, here some historical values are visible over the last day, the last week, such things are possible. But this widget here is empty and the user can create it independently like he wants. So, but all these energy analyzers have a lot of more functions. We have inside, for example, the menu analytics, a historical database. So all meter values for at least minimum 3 years of all meters, 16 or 64 meters can be connected, are stored. We can make a benchmarking of some meters or meters nodes over the same time period, or we can do more things, for example, via the reports. So the energy analyzer can send also via emails or via FTP server upload some meter values to a FTP server, for example. We can configure alarm ranges and a lot of more things. So the only thing about the KNX, or the difference to the KNX Energy Analyzer 116, is that this device is completely configured in the ETS because it's a standard KNX device with a programming button and a bus terminal block. So it is handled like a standard KNX device. So we set the parameters, we link group addresses, we make the download. This everything is done here in the ETS. So, but what is now new in the KNX Energy Analyzer is the load control function. So this is only available in the KNX version because we want to switch off something, and this is only possible via KNX. So for more information about this energy analyzer KNX or the Modbus or MBUS energy analyzer, please visit our recording of the webinar we have given in January about this energy analyzer or the presentations. You will find the links here in the feedback email or also on our training and qualification database. So here, last three slides about this energy analyzer. In principle, three hardware. You see they look all the same, but only the protocol is different. KNX, MBUS, Modbus. So the devices, the energy analyzer store all the meter values here, and via a standard browser, the end user has access and can read out the values, the historical data, can do the configuration, everything else. So, and all three analyzer send via email the meter values, for example, to some email recipients or make an upload to an FTP server. This is in all three devices basic function. But what else? All three energy analyzer can also or provides the data for Modbus TCP or via REST API. So independent which device is it, which protocols it works. And though, for example, we can use these meter values in our building automation controller or, for example, in a SCADA system for analyzing or for processing of values. And on top, these devices here, a SCADA system or our building automation controller, can also convert these Modbus TCP meter values into KNX net IP telegrams. For example, they can then be forwarded to an IP router and here sent in a KNX line. So here on maybe on your Smart Touch KNX device, you can see the meter values of the meter which comes here from the KNX or from MBUS or Modbus. So for example, if you have here a water meter connected to MBUS, the device can send the values via Modbus TCP via the building automation autocontroller here into our KNX line. So it's a big world, so we can do really a lot of more things. But today I want to continue and to show you at the first step how we can handle the meter values in the energy analyzer. So here on the left side, we have the KNX Energy Analyzer 1.16.1. It means he can listen to or evaluate up to 16 different KNX meters. So this can be, for example, the so-called KNX meter interface, ZSS. So the meter interface get all meter values via the infrared interface from a typical ABB energy meter A series or B series. So all these meters send via infrared the meter values, and the ZSS converted it into KNX telegrams here to our energy analyzer. Another meter can be, for example, the energy actuator, SES. This is a switch actuator with 3 channels and built inside the energy meter. So here all the meter values can be measured, power, energy, frequency per channel or per complete device, and sent here also to our energy analyzer. Another device is so-called energy module, EMS. Energy module is only for measuring the energy or the power. Maybe here up to 20 amps are possible. This is like the energy actuator without the relays. And of course, what is now possible to use the switch actuators with energy functions, the X1662, to send here also the meter values per channel or per energy group here to our energy analyzer. And of course, it's a KNX system, so we can also talk here to other devices, like for example, gas meter, gas, water, or heat meters. So maybe some third-party devices can also send meter values, and we can make it also here visible. Not only maybe electricity meters, all kind of meters which can send meter values via KNX. So here an example. Remember, the energy analyzer can listen up to 16 meters. And the ETS will say, okay, my meter number 1 is, for example, my meter interface, ZSS. Meter number 2 is here my energy actuator, my energy module, for example, my meter number 7. And then I come here to the switch actuator. The switch actuator, I can set here, okay, the channel A, my channel A, send his meter values to the meter number 3. So in the energy analyzer, I get all meter values here of my channel 3. So the next possibility is to create so-called energy groups. Maximum we have 4 energy groups. And then the ETS, we can say, okay, my energy group number 1 gets meter values from channel A, channel B, channel C, and channel D. So the energy group sums up all 4 channels, A to D, and send the meter values here to my meter number 4. Number 5, my meter number 5 in my energy analyzer is, for example, my output number G. and my meter number 6 is my complete device. So I create another energy group number 2, and my energy group number 2 exists of A, B, C, D, E, F, G, H, and so on. So this is then the complete energy of my switch actuator 8-volt like I have it here. That's exactly what we can see here. The overview, meter number 1, my meter interface, number 2, energy actuator. So I get the meter values per channel, A, B, C, and total of all 3 channels. Switch actuator, channel A is my energy meter number 3. Number 4 is my energy group number 1. You see, I get the total values of A, B, C, and D. Meter number 5 is my channel G, and my meter number 6 is my energy group number 2, so I get a total meter value from channel A to H. So to see these meter values later, we use a so-called dashboard. That's what I show you, what I show you now live after some slides. So then let's go to the parameter settings of the ETS. So we start here in the Energy Analyzer QAS. So remember, meter number 1 is my meter interface. So I go to the ETS parameter, say my meter number 1, and I select here, I want to communicate here with my meter interface ZSS. And then I get here a template of all the parameter which are required for communication to the ZSS. So at first I can enter here user-friendly name, the location of the meter, a serial number. So next parameter is a group object request meter sensor reading. When I say yes, and then the energy analyzer sends a telegram, a 1-bit request to the meter interface, and the meter interface responds with the meter values. So, and I can also monitor the communication between the meter interface and the energy analyzer. So when I say yes, then I can say okay, with which information, value 0, then I get another group object for in operation monitoring. I can say value 0, value 1, or both values are possible. So then I have to set exactly the same parameters in my meter interface. So when I say yes, for example, every 130 seconds, then it makes sense that the meter interface, for example, send every 60 seconds the value 0 to show yes, the communication is still okay. And then I have to set here some meter-specific parameters, like I have set it in the ZSS, a 2-wire, 4-wire with tariffs or other tariffs. What is now important is here the parameter. If the power values should be used in the load control function of the energy analyzer. Yes or no, of course, we want to use these values, and then we have to tick here. Good, and then we get exactly here this group object of my meter number 1. Like for example here the active energy, the active power, the current, the voltage. This is the example for this single phase meter. And to link the group objects, I think it's not really difficult. Here on the left side, we have the energy analyzer. You see exactly the group objects in operation, request meter reading, and so on. And here on the right side, the group objects of the ZSS meter phase. You see nearly the same, the wording is the same. And then we link here the group addresses. Like for example here, the active power from this group object, we link it with a group address here to this active power. This is, I think, not really difficult. So we need here some group addresses. So then let's come to the energy actuator. This is, for example, my meter number 2. So here in the energy analyzer, I say meter number 2. I select here my template, you are energy actuator, and I get again here the parameters which are needed for the communication between the energy analyzer and my energy actuator. User-friendly name, where the device is installed, again the metering, the request for the metering values, the in operation, yes or no, and again, if all the meter values should be used for load control. I can say yes for all 3 channels, A, B, C, or only A and B, but I want to have all values here for load control, so I enable it here. So then I get here the group objects for linking the group addresses with the energy actuator. Or here again, on the left side, when I've selected communication with an energy actuator, then I get exactly here this group of objects, and on the right side of my energy actuator. And you see exactly here the same name. You have linked this group object, active power, with this one, the frequency with this one. So it's really simple to link here the group addresses between the energy actuator and the energy analyzer. So for the complete device, for channel A, for channel B, and for channel C. So then let's come to the switch actuator with energy functions. Here there's also some parameters we can set. So at first, in our energy analyzer, we have to select here our template electricity meter generic. So at the moment, we don't have a special template for a switch actuator, so we use here the generic settings. So we can enter here user-friendly name. We can also set here the request for the meter values. Yes, we can do the communication monitoring, yes or no. The voltage network, yeah, here we have to set that we communicate with a two-wire meter, because here our switch actor, our channel or energy group works like a two-wire meter. So no tariff, of course, and we have to use here the data point type 13010 for active energy in watt hours, because the energy analyzer works with watt hours. Do not use kilowatt hours or the 8-bit values. And again, if we want to use the meter values for load control, then we say here, of course, yes. Good. The group objects of the energy analyzer, when we say generic, you see we get here the active energy, the power, the current, and so on. So then let's come to the parameter settings here of the switch actuator. So at first we go here to the first menu, which is the current measurement. We have to set here, we want to get the meter value, the current in amps. So this is the official data point type 14019. So please set here A. Then we have the delay time for measuring. So after 3 seconds, after the contact position has changed, then he evaluates the current. So when the value should be sent, at a change, at a request, or also cyclically. So you can then enter here the time, maybe every minute, or for example, when it changed in percent, like 10% of the last sent value. Good, then let's come to the energy values. If you want to send it also to the energy analyzer, then we have to go to our switch actuator, to the template or to the channel. You see here, switch actuator channel A. So we can do the settings per channel. So we go to the submenu, energy functions, and we enable, yes, please use the power calculation and the energy consumption. And here you see we can link the output A to energy group 1, to energy group 2, or to all energy groups. So then we come, when we have enabled it, then we get another menu, the so-called power calculation. So in the power calculation, we have to enable here the parameter in watts, because the energy analyzer wants also the watts. So the voltage we need here for the power calculation. So the voltage can be used as a fixed value here, or it's also possible to send it via a group object. Default 230 volt, and for example here for calculation of the power we need also the power factor. So again, the power factor can also send via KNX telegram or changed in the user interface later. So in here, when should be the values, the power should be sent, changed, request, or cyclically, and here the time for cyclically sending. So then let's come to the energy values, like here in watt hours. So if you want to use it, then we enable here the active total meter values. The same should be sent every minute, for example, or when the value changed of 10% between the last sent value. And remember, for calculation the energy, we need a time. And so it's recommended to synchronize the internal timer of the switch actuator from an external time master, like a weather unit or other KNX devices, for example. They can, or the energy analyzer, for example, he can receive time and date via the NTP time protocol, via the internet, and can send time and date here to the switch actuator to synchronize the internal timer of the switch actuator is also possible. Good, and then we see here the group objects per channel. Channel A, for example. Of course, we get a typical objects for switching and so on. And you see when we enable the current measurement, then we get here the object state is current. And where is it here? We have the power and here our active energy in watt hours. And if you use additionally the energy groups, maximum, we can have up to 4 energy groups. Like here my energy group number 1, then I get again current, power and energy. So every time these 3 values are sent per channel or per energy group to our energy analyzer QoS. So how to link the objects between the energy actuator with energy switch actuator with energy function, and here on the left side my energy analyzer. I think it's not difficult. At first we have some address for switching and to get the status of the switch actuator. If we want to use the monitor the in-operating function, so that he send every minute here live signal, then we need a group address, or the energy analyzer should send here a request to get the meter values, then we link another group address. So then we link the group addresses for the current here to the object current, for the power to the object active power in the energy analyzer, and here the energy consumption. So we need here minimum these 3 group addresses, and of course we can have more. So, and for the energy groups, it is similar. At first, we need 2 group addresses. If we use the in operation monitoring, or to read out here, to send here read request, we need a group address. And again, for the current, power, energy, we need 3 more group addresses. Good. So far, then let's come to a practical demonstration. I share now my desktop. So here you can see my standard browser. I have here to enter the IP address of my energy analyzer QS. I have now done it. So, and reload. So I enter here my username. I'm the admin. Then I have some more functions in the energy analyzer, and to enter here the password. Good. So then now I'm connected here with my energy analyzer QoS KNX. So you can see here the menu, the dashboard. This is at the beginning empty, and the user can configure here his own dashboard. Then we have other menus like analytics, the load control, and for the admin, additionally, the management and the system menu. So here on the left side, you see the meter values, which come from the meter interface. This is my meter number 1. You see the energy, the power, the current. So or here, this is my switch actuator, my second column, channel A. You see the energy, the power. At the moment, it is switched on. I can switch off now my channel number B. It was number B. And now when I switch off channel number A, you see it goes down to 0. I have here connected incandescent lamps, so 25 watts per channel. So I switch on again my channel number A. You see here the power and the current. Channel number B of my switch energy actuator, the same. Here on the column number 5, I have my switch actuator with energy functions. My channel A. So when I switch on this switch actuator, you see here again also 25 watts. And my energy group 1 shows also 25 watts. Remember, in my energy group 1, I have linked output A, B, C, and D. So now when I switch on output number B of my switch actuator, you will see here it goes up to 50 watts, 52 watts. So these are here the so-called meter values. Another nice menu to see the meter values is here the menu Analytics. Analytics, we have historical data, and here we have a so-called instantaneous value menu. Instantaneous means I can see here, for example, the instantaneous values of my switch actuator. My channel number A, you see at the moment the active energy, 314 watts, 25 watts, this is my power. When I switch off my output A, you will see it goes down to 0, and no current flows. For the energy actuator, of course, I have some more functions. Here I get additionally also the voltage, for example, I get the frequency and so on. I get the meter values here total for the complete device, at the moment 50, because my output A and B is switched on and my output C is off. You see here power, output number C, which is here labeled LSV, is 0. So, and here we have 25 watts channel B, 25 watts channel A equals 50 watts. Good, so far the so-called meter values. Then let's go back to the load control. So load control means our master, which is here our energy analyzer, get all the meter values like I have shown you before from devices, and via the load control we switch off some loads. This can be, for example, the energy actuator or our switch actuator with energy functions. And what is also possible, we can also switch off some loads, like in a standard switch actuator like professional, or in the combi, or in a fan coil controller, fan coil actuator, or split unit gateway. These devices cannot send the meter values to the CDSS, but we can integrate these devices. Maybe the meter interface here measures the energy, for example here from our fan coil controller or from our split unit gateway, and via load control we can switch off these devices. Here on the left side, this is very easy because here we can use a 1 byte information, and here we have to work with the 1 bit information because these devices, they don't have this priority object. Good, this is what I show you now after some slides live. Let's come to the parameter settings in the energy analyzer. Of course, when we want to use the load control, we have to go to the first menu and say yes. Then we can enter here how many shedding stages we want to use. Yeah, from shedding stage 1 to 8. So the energy analyzer, he sums up all the power values, and then when the power values exceed our limit, and then he send he send the command shedding stage number 1, and then all devices which are linked, which actuators outputs with this first shedding stage, switched off the load. If we are still above our limit, then is then shedding stage number 2, number 3, 4, 5. So we have here different priorities depending on our shedding stage. The load limit here, for example, in my exercise, 100 watts, because I have here 25 watt incandescence lamp later for the practical demonstration. Do we want to change the load limit via group object? Yes or no? The reaction time when the load limit exceeds, when the active power exceeds our load limit. So after 2 seconds, then he starts sending out this shedding stage. And when the value, the power, falls below the limit, then the energy analyzer waits here minimum 30 seconds or longer, and then he reduces the shedding stage backwards. We can enter here hysterese, and if it's possible to, for example, change also the values via the web user interface, yes or no. And when we make a download, should all these values we have maybe changed via the web user interface overwritten, yes or no. And if the load control is active or deactive, for example, after bus voltage recovery. So then we get here the objects. So what is important now here, of course, time and date. We can the device can receive time and date via the NTP time server, or also here and send it then to a KNX switch actuator, or can also receive your time and date via KNX. So both directions are possible. So object to activate or deactivate the load control, the summed up values. And for our load control, we get here a 1 byte object, so-called send load shedding stage, and it's a data point type 236.001 for priority. So now when everything's okay, if our value, our power is below our limit, then this object here has the value 0. And if the power value exceeds our limit, and then this here is the value 1, 2, 3 or higher. Another possibility is to use these shedding stages as 1 bit informations when we work together with the fan coil actuator, for example, or other devices which cannot listen here to this priority. So then we get, for example, here up to 8 1-bit objects. Good, then let's come to the parameter settings in the energy actuator for load control. I think it's not really difficult. You go to the function, you enable here this receive load shedding stage, yes, and then per channel we can use it again. So it selects here channel 8, yes, please use this, and then we have go to our channel, check channel A, and enter here the shedding stage per channel A. Like 2, the channel B can be maybe listened to the shedding stage number 4. So we have different levels of our shedding stage. So and he receives the value via group telegram. So then we will see we get 1 object for load control per complete device, and then we are this here receives the energy actuator this shedding stage. So if we want, we can change also the set shedding stage per channel via this object. It's a parameter to enable yes or no, and we can also deactivate the load control per channel. Again, here's A, B, and C is also possible. So in the switch actuator, if we want to use here the load control function, at first we have to enable the outputs and the energy functions, and if you want also here our energy groups. So then we go here to our channel, like my channel number A. I go to the menu functions, and here I have here the parameter enable function load shedding. I say yes, and then I get a new submenu load shedding. This is per channel. So in here then I can use the template or can do the individual settings, and I enter here my shedding stage. 1, 2, 3 or higher. And I can also enter the shedding stage via group object if I want, or override, for example, during a download is also possible. So now what is now important here is the reaction on an active shedding stage. like we are above our load limit, and then the energy analyzer sent shedding stage number 1, the output A listens to shedding stage now 1, and then he switches off the output, which makes, I think, 99% sense. But in some cases, I want to switch on a load. Why not? Maybe if I want to switch on a siren or a buzzer or some flashlights, yeah, to indicate, oh, we have now exceeded our power limit, then I can say on. And the other way is, when the shedding stage 1 goes to 0 backwards, what should happen? Reaction on revoke of load shedding stage, no reaction, then maybe the output A remains off, or we can say no, go on, go off, or go to the last received KNX value the output has received via the object switch, for example. This is also possible. Good, and then you will see here the objects. We have one central object for the complete device. Here receives the shedding stage with the priority object. And then per channel, like here channel A, we can also change here the shedding stage via a 1 byte telegram we can also do. Good, okay, how to link the group addresses? I think it's not really difficult. We have some group addresses like here for time and date, and in our switch actuator for the channel or the energy actuator. But what we need is one group address, link it from our energy analyzer, from the load shedding stage, our 1 byte priority telegram, here to our switch actuator, to the central object, and to our energy actuator. That's all. So we need only one group address. Remember, this is the group from the data point type priority control, and it can have values between 0 and 15 depending our shedding stages. Good, and how we can integrate other devices which cannot listen to this priority telegram or which have no energy functions, like our combi or standard switch actuators. We use the so-called forced operation. So we have to use here the 1-bit forced operation functions. I think nearly 99% of all KNX actuator, if these are switch actuators, dimmers, fan coil actuators, controllers, have this forced operation. So you go to the settings, functions per channel, enable here priority, safety, yes, and then you get here the submenu safety, and in the safety we have here block, we have priority, and here we have forced operation. You can select between the 1-bit and the 2-bit priority forced operation. The 2-bit was from the beginning of the EIB system, but today we use the 1-bit. So here you set activated 1-bit, but 0 active. This is important. Now we have here our 1-bit telegrams, and if the shedding stage is deactivated, so we are below our limit, the value here is 1 because everything is good. And now when he sent out shedding stage number 1 via 1-bit telegram, and then this value is 0. That's why we have to select here the parameter 0 active. So this little bit, maybe a little bit let me say this is a bit different like default, because if we activate something, we send the value 1, but here if the energy analyzer activate the shedding stage number 1, he send a 0. So this is here important to say 0. And of course, the switching status, if the forced operation is active, off or on, typically off, then we can switch off here our standard switch actuator. Good, the object, remember we have per channel our forced operation, like here channel A or channel B. So how to link the group objects, it's not really difficult. We cannot use our 1-byte object, we have to use the 1-bit. So we can link, for example, the shedding stage number 1 here to the forced operation of channel A, shedding stage 2, for example, to here to my channel B. And the other shedding stages are the same here to channel number C, every time here to the object forced operation, because force has the higher priority than here switching. So this is what we can do with the 1-bit shedding stages objects. So, and via this 1-bit, we can also control other devices like fan coil controller or split unit gateways, because also these devices have in the menu monitoring and safety the forced operation, like our switch actuator. But here again, 0 active, and then also we can enter here the parameters, what should happen if the forced operation is now triggered by the shedding stage, off, on, or here default control value. Good, and here you see again the object forced operation, 1-bit of our fan coil controller. So to link the group addresses, I think it's not really difficult. You have here maybe also some group addresses for the fan coil controller, but we use here again the 1-bit information, shading stage 1, 2, 3, 4, what do you want, and link it here to the object forced operation. Like here in a fan coil controller or in a split unit gateway or a DIM actuator or what do you want. Good, then let's come to a practical demonstration. Share now my desktop. So I go now to my menu load control. You see at the moment my load here is my limit. At the moment I have here 110 watts. My actual load here, my power, is about 75 watts. You see here on the right side all these devices which send meter values for load control to my energy analyzer. At the moment my energy actuator 50 watts and my meter interface 25, so I have now 75 watts. You can see here total power 75 and it is stopped. Then I activate now here my load control. You see the status on the left side, it is still okay. And I switch on, for example, here another load, like here switch actuator, channel B, and you will see channel B of my switch actuator. You see channel B, he send these meter values to my energy group number 1. I have about 100 watts, and now I switch on channel A, and you will see what happens. He waits 2 seconds. You see I'm above my limit. You see here above the limit, and then the energy analyzer after 2 seconds he starts sending here the shading stage 1, 2, or for example also shading stage 3. It depends how big is the difference between the load limit and the power above the load limit. Good, at the moment shading stage 2 is active, and then after 30 seconds the energy analyzer reduces or goes backwards with the shading stage from shading stage 2 to number 1 and checks if the energy is still below our load limit. Yes, then he waits again 30 seconds and then the shading stage number 0. If not, then he still send again the shading stage or the next higher shading stage. Good, this is a short impression how this load control works. Of course, you can also do some changes here. It is a parameter in the ETS. Let me stop. And I can click here on the button Edit. And via Edit, maybe the end user can change here also the load limit or the hysterese or the reaction time for falling or for exceeding the load limit. This can be also done here. Good. Okay. So far, then I think it's time to hand over to Thorsten. So far, this was my presentation. Thanks and goodbye.
Yeah, thank you, Jürgen. Great. So a lot of functions inside. I'm sure you could not follow every point in our bit longer session today, but see our session, the record you get later also as a kind of guidebook. You can repeat later, maybe you would like to go in some more details, but I hope and we think it's useful for you. Allow me to go quickly at the end to my typical last slides. So first of all our content you get on internet, product-oriented training material in our training and qualification database. Our calendar at the moment only online trainings, and at least for this year no classroom trainings possible anymore, but we are optimistic for the next year. We plan accordingly and will inform you on time what's going on. But what are our next sessions, online sessions? So the webinar, the final one for this year in December 16th, about free at home API, application programming interface, a kind of open software or a programming interface to other systems, whatever it means. So there is a kind of community already behind, and also the first implementations, and Martin Vichare will inform about the actual status and what is possible there. There's a developer portal also behind, and we give you also some practical examples. So API is a topic, application programming interface. And next online learning session this week about push control touch on Thursday. Integration of lighting control with Philips Hue. So integration of KNX via control touch with Philips Hue lighting. A topic we got a lot of requests to talk about. And then the last 3 online learning sessions this year in December about ABB Free at Home again. We go to some basics again, overview installation, kind of products available and so on. third-party integration, and the DALI and split unit gateways we would like to explain a bit more detailed. So thank you for your participation, for your patience today. We sent you the feedback email still today, the PDF of this comprehensive presentation. Hope to see you next time. Bye bye, ciao.